Okay, so next, our gold sponsor, XM, is an international fintech company with the vision of innovatively shape the future of online trading. And please welcome from XM, Senior Cloud DevOps Engineer, Chris Xystras. Resiliency verification through chaos is the speech that he's going to give us. So
Thank you.
Welcome.
Thank you. Hello, everyone. Thank you for your attendance. My name is Chris, and I'm a Senior Cloud DevOps Engineer with Trading Point. Been with Trading Point for the last couple of years. Before Trading Point, I was working with AWS in Dublin, Ireland, as a support engineer and systems engineer. So today we're going to have a brief chat about resiliency. We're going to go a small walkthrough of our process that we have established through chaos. A little bit about the Trading Point. We are an online trading platform, broker firm. Since 2009, which was our inception, we have established a very strong client base, more than 5.5 million customers across the globe. We have expanding in multiple continents, and our headquarters are in Cyprus, but we have remote offices around the world, Athens, and soon Thessaloniki for Greece, the UK, America, and so on. We have about 800 colleagues, most of them in IT, more than 350. And we gained multiple awards, especially for Great Place to Work awards. For 2022, we were first place for Greece and Cyprus. And we also went to the European awards, which we acquired the second place. That was among 5,000 companies. So let's see a little bit about our architecture. By the way, I should also mention here that the slot for this presentation is ideal right after Kubernetes security. And from yesterday's talk of Suzanne for Backstage, when she mentioned embracing chaos, this comes a little bit to tie very nicely. So we have started as traditional on-prem, then moved to colocation, and now we are moving to the cloud. Most of the companies do that, and we shouldn't be any different. We have, at the moment, more than 16 clusters. We are using EKS mostly. We have more than 1,000 deployments, and we are using more than 180 daemon sets. We are working also with other cloud providers, not just Amazon. We're working with Azure, with Google, with Oracle as well. And regarding Amazon, we are using more than 100 services. And not just those, we are also using third-party tools like New Relic, ELK, etc. So let me say a little bit about why chaos engineering is a good thing. It's not just a license to break stuff. It can flush out issues, mostly resilient issues, but not only. It considers to be now, and it is, a need to have if your scale is quite big. It's not easy to test once you have 1,000 machines as a fleet. You can have better reviews and more in-depth. So through chaos, you get your findings. You see what broke. You go down, you do your root cause analysis. You find your findings detailed, and then you pass them on to be fixed. The try to break it methodology, it's something that started a little bit before it was named to chaos. You're also are aware of the the new methods, not the traditional ones, like working backwards from a problem, etc. And it also gives very nice overview to the business guys, to the business people in your organization. It's not just for engineers. For example, reports could be either in-depth or overview, and you could also expose them to your stakeholders or your C-levels, like we are resilient at this and this and this point, but these points need to be worked at. It's much, much better to say it in advance rather than excuse yourself later on. We didn't see that, we didn't know that. Prioritization also of what needs to be fixed is very, very important. And actual remediations, you are not mitigating. Once you have a finding from chaos, you're not mitigating, you're not patching it so that you just go along. You're actually doing the remediation. You need to solve it because it will pop up on the next wave or your next cycle of experiments. So it's a cool thing to do. I'll use a fictional story to drive this around. We have Artemis or Artemis, try to be gender neutral, so whichever you prefer. It's an engineer, a fictitious engineer that we trust. It's not that tenured, but there is good opportunity, good possibility, good in investigations, thorough, trust the metrics, the process is correct, etc. And we have asked if we are resilient. Artemis said, we are. Yes, we can even lose an EKS node and we wouldn't feel a thing. Guess what? We felt it. So this gave birth to our first experiment, our first also experimentation with chaos, the node termination. A little bit about how we are doing it. In AWS, we are using FIS, Fault Injection Simulator. It's a service provided by AWS where you have ready-made experiment templates that you can use and adjust as you wish. And there is nice features like metrics to enable stop condition. Say, for example, you are causing an outage on your website. You have a metric in CloudWatch when you say that the website is down for 1 minute. That can act as a stop condition for the experiment, so the action taken by the experiment stops. And you are just imposing the failure you want to test for a certain period of time. Also, logging is a nice feature always to have. It's a must feature to have. And through the experiment templates, which are actually SSM commands or predefined SSM commands, you can run your action, you can trigger your action. So in this case, we were terminating a host and we expected to see the automation to pick that up, to realize that there was one node missing and spawn a new one. So we did so after some tries and corrections. Pods shifted from that lost node to the other where possible, and a new one at the same time being respawned. As I mentioned, this was not right out of the box. We went a little bit back and forth. We corrected a few things, and we finalized that to be one of the experiments we are running periodically. Next up, it's a little bit one click more advanced experiment, the stress test and the simulation of the AZ failure. Again, with FIS, the stress test to simulate, let's say, a rogue pod, a rogue application that would be resource hungry to a great extent that would affect others. Let's say limitations were not correctly set, or for whatever reason there was a bug or a vulnerability that was eating up memory or a memory leak or whatever. So we did show that in the action, and again the automation picked it up, spawned a new node, shifted pods around, rebalanced a little bit. This is a correction we took. We realized at this point that our rebalancing was not that correct, so we adjusted it. And then it went on. After the experiment was stopped, our stop condition was for a period of 5 times. One of the two nodes, the old one and the new one, was terminated, and pods were rebalanced again and shifted. The other experiment, we tried to simulate the easy failure. Back then when we were doing it, there wasn't a ready-made experiment. Now Amazon has added a ready-made experiment. There is a network disconnection where you can disconnect a network, a subnet, from others. Back then, what we did, with tagging, we selected the nodes that were in one specific subnet in one AZ and terminated them and changed a little bit on the auto-scaling group. So we saw additional nodes being spawned in the other two AZs that considered to be okay. And if you recall, and if you were working with Amazon maybe 3 months ago, there was an incident with one AZ in EU West 2, London. For that matter, I can say that we weren't affected to the extent that we would have been if we didn't run these experiments before. Last but not least, our advanced pack, something that is, the experiment itself is fully custom from our engineers. We are testing, firstly, pod deletions. Let's say, for example, there is a rogue action or a malicious action, or we're trying to see how the respawning of pods is done, how fast it is. We have 2 versions of this experiment. We have all but one and -1 pods, and all pods. We have seen that the automation is working as expected. The deployments, some of them had the correct settings, some didn't. We gave advice back to the owners. They started correcting things. And last but surely not least, our request swarming. This is one of the most important ones. You can never estimate how much traffic you can get. This is the era of exaggeration, of swarming. You see something in the news, goes viral immediately. You have multiple times of the traffic you are expecting. So we wanted to see our breaking point. We wanted to see if our systems were able to handle that load, that much traffic. So we did that through request swarming. It took us quite some time to establish what is required, the correct format of how it should be. And we came up with 2 flows, internal for internal applications and systems, and external for simulating customers' load. Both of those were triggered from a separate node group in the EKS cluster so that we wouldn't have the limitations and we would still be valid on the assumption we would take. This is slowly getting into our release pipeline in regards to web applications, and every release will be having this experiment as a pre-check and findings to be verified. All these are the tools we needed so that Artemis, or Artemis, whichever you prefer, was more able to provide the correct answer. We are not penalizing, we are not accusing, we just didn't have the right tools at that moment, which is okay to have. We need to evolve as an organization, as systems, according to new methodologies. And the findings we got: bring your own data, get your data, back up your position. Don't just trust your hunch, your gut. You have to provide data always. It's much, much easier to validate the data. It's more accurate, of course. And it can also provide, as I mentioned before, different angles. Different angle for an engineer, different angle for a senior engineer or a principal engineer, different angle for a stakeholder or a CEO. They don't need to know the specifics, they just need to understand the gist, the general idea of it. This enabled us as well to test everything, not just the traditional ones, functional, non-functional, operational, load specific. We also tested resiliency, and through resiliency we tested pretty much a bit of everything else. The experiments were run also in the beginning a little bit ad hoc in the form of waves. Now we are adding them as regulars as well. And we are, in the chaos methodology, we are also adding the backup restoration exercises. We were running it separate at the past. You think you have your backups taken until you need them. So that is also something to test. What it helped us as an organization, chaos, a few of our achievements, our corrections, we had prolonged node replacement times. As I mentioned, through the first experiment, we corrected that. As also the previous lecturer mentioned, we didn't have that much light images, which was killing us. Recalibration of alarms and thresholds, and also the rebalancing. We revamped our logging. We saw that at some places it wasn't that much correct, so we saw gaps in our logs, and we dove deep to find them and correct them. We also realized that there was an IP release issue that was, if I recall correctly, a little bit attached to the AMI provided from Amazon. They corrected it in their next release. And of course, we verified our auto-scaling, either those being within the cluster, either those would be outside the cluster. Incident response management exercises, they were for us another way to test the response, the task force. The calls were done correctly, people were added to the calls as they should have been. Later on, they would be informed that this is a chaos experiment, and they would still carry on their process just to simulate. The more you practice, the more ready you are when you have the actual fault. Transparency throughout. No one can tamper with the results. Not even the team that runs the chaos experiments can tamper with the results. We are also working on automating a way for a dashboard to visualize the results without manual actions. And of course, we are trying to run everything through chaos that can be run. I will close with this. Keep breaking it until it can be broken no more. Thank you very much. I'm Chris, and we are XM right out across the booth. Thank you.
Thank you so much.
Thank you.
Very insightful presentation regarding resiliency of services, because that's, at the end of the day, that is what counts the most when you have a service company. So thank you so much.